Hello everybody. These are going to be the video notes for 7.5, which is vertex form. We only have one vocab word today, and that is vertex form. This is going to be a formula or an equation that is on your formula chart. And you will see this, this formula pretty often with quadratics, and you've actually kind of already seen it before. You just didn't know that it was vertex form. So vertex form is y equals a times x minus h squared plus k. Now, the reason it is called vertex form is because this form gives you the vertex of your parabola if it is in this form. That was terrible. Anyways, vertex form comes from this value and this value. And what happens is those two things come down into the ordered pair for your vertex. Whatever your x value is of your vertex, that is actually the h value in vertex form. Now, in vertex form, it's a negative h, but that just means that whenever you take the number out of your vertex, or if you're putting h into your vertex, you have to switch the sign. So in vertex form, it's negative h, but down here, it's going to be a positive h, and then the k doesn't change signs. But this right here is actually your vertex. So if you know what your vertex is, that number just gets plugged in here for h, and this number just gets plugged in here for k. H changes sign, k does not. Okay, so we've already done transformations of quadratics, and that is a similar look to what vertex form is. So it says in the last set of notes, we talked about quadratic transformations. List the quadratic transformations from this equation. So here we have just a transformation equation. Remember that this thing right here determines if your graph has been reflected. This is an x-axis reflection. The number that is inside of the parentheses but to the right determines right or left. This would be a left 2. And then this number down here actually tells you that your graph has gone down 3 units. Now, that transformation equation looks very similar to vertex form. There's only a few things that we would change, and really the main difference is we remove the letter f from our transformation equation, and then we add a squared into vertex form. So notice that up here, this f doesn't exist at the bottom, but now this squared does exist, but everything else has remained the same, okay? So hopefully the differences that you notice are the f is gone, and we've replaced, or we have added a squared onto our parentheses. And I've already talked about this, but vertex form is called vertex form because the form itself gives you the vertex of your parabola. All right, so I could give you an equation in vertex form like this, and what we are trying to do is we want to list the vertex, the axis of symmetry, if our graph has a minimum or a maximum. If it does, or it's going to have one, but whichever one it does, we need to list the min-max value, and then the domain and the range. So what I'm going to do is I'm just going to rewrite my equation over here so I can look at it a little bit bigger. Okay, so the first thing that I want to do is look for my vertex. And as a reminder, your vertex comes from this value and this value. That's your h and your k in vertex form. And whenever we pull the vertex out of vertex form, the h value has to change signs, but the k value stays the same. So instead of it being a -5 that I plug into my parentheses, I'm actually plugging in a +5. But my k value, that -1, stays a -1. So this guy comes over here, and this guy comes over here. We don't have to graph this to know what our axis of symmetry is. Our axis of symmetry is just the x value of our vertex. So because the x value was 5, our axis of symmetry is going to be 5. Okay, our minimum/maximum is actually going to be determined by this number in the front of our vertex form equation. If your number is a positive, then that means that your parabola goes this way. If that number was a negative, that means that we would have had an x-axis reflection, and it would be facing the other direction. It would be upside down, and it would be a maximum. So because we have a +6, that means that we have a minimum, because my graph looks like this. Your min-max value is the y value of your vertex. So that's going to be y equals -1. Your domain for quadratics is all real numbers unless there's a restriction on it. And then I know it's been a minute, but you can find your range by looking at both your min-max direction and then your min-max value. So we have a minimum, okay? So that means that my min-max value of -1 is going to be there. And then all of our y values are going up. So our y's are going to be greater than or equal to -1. If I look at this equation in vertex form, again, I'm going to look at my vertex. My vertex is coming from these two numbers, this guy and this guy. And remember that the x value of your vertex, when you pull it down into vertex form, it has to change. So because it was a -1 in the parentheses, it's really a +1. And then that +4 at the back is still going to stay a +4. Your axis of symmetry is the x value of your vertex. To determine if you have a minimum or maximum, you need to look at your a value, or that number in the front, and that is going to tell you that if you have a parabola that opens up or opens down. Because that is a -3, that means that my parabola has actually reflected across the x-axis and now it's upside down. So now we have a max. That maximum value will be 4 because that is the y value of my vertex. Your domain is all real numbers, and remember that your min-max and your min-max value will help you with your range. 4 is my maximum value, and all of the y values go this way, so y will be less than or equal to 4. Okay, so what we're going to have to do is write equations in vertex form, and just as a quick reminder, vertex form is y equals a times x minus h squared plus k. This is on your formula chart, so you never have to memorize it. It says, write the equation of a quadratic function in vertex form that has a vertex of 3, 6 and passes through the point 6, 5. So what we want to do is we always want to determine which coordinate is our vertex. So whatever it tells you, that is going to be your h value and your k value. The other point that it gives you is important, but we're going to do something else with it. We are going to list our point as x, y. And what I want to do is I want to plug in those 4 numbers, okay? The 3 and the 6 from my vertex and the 6 and the 5 from my point into the letters in vertex form. So you see how vertex form starts with y equals. That means that the first number I'm plugging in there is my y value, which is 5. The only value that I do not know right now is my a value. Everything else has a place. So this is how I always start vertex form. I always start it with writing down my vertex form equation. Okay, we know that y is 5. We do not know our a value. We know that our x is 6. We know that the h value of our vertex is a +3, but remember that when we plug it into vertex form, we have to change its sign. And then our k value we said was 6. So all of these numbers I've gotten from the pink coordinate and the green coordinate. And the only letter that I do not have now is a, and that is what I have to find. So from here, I have to follow PEMDAS, which tells me to do parentheses first. So we have 5 equals a times 6 minus 3 is 3 squared plus 6. From here, I will have to do 3 squared. Now, one thing that's really important for you to know is after you square the number that you get in the parentheses, put that number in front of a, do not keep it at the back of a. So instead of it being a times 9, this is going to become 9a. And I know you're like, why does that matter? Just trust that it does. From here now, I just have a normal equation, so I'm going to solve for a. I'm going to subtract 6 on each side, and I get -1 equals 9a. From here, I will divide everything by 9, and I get that a equals -1/9. Now it says write the equation of a quadratic in vertex form. This is not vertex form, that's just A. So when we rewrite our equation in vertex form, I only need two pieces of information. I need my A value and I need my vertex. I do not need my point. Do not put your point back in. You only need your point once. You need your vertex twice and you need your A value. And our actual equation will be y equals, I now know that A is -1/9, so that's going to be -1/9. And then I have to do x minus the h value plus the k value. And I need to scoot that down because that's too close. So that is my equation in vertex form of a graph that has a vertex of 3, 6 and pass it through the point 6, 5. Let's do another one. I'm going to skip number 2, and instead I am going to go down to number 3. Number 3 says, write the equation of a quadratic function that passes through the point -3, 21 and has a vertex of -6, 3. So it's really important that you pay attention to the order that they give you your coordinates in, because sometimes they'll give you your vertex first and sometimes they'll give you your point first. So they actually gave me my point first, so I'm going to make sure that I label that x and y. Your point is always x and y. And then your vertex, this other thing over here, will be h and k. So I have y equals a times x minus h squared plus k. And then from here, I plug in all of my known values, which is literally everything other than a. X is -3. H is a -6. So that means that when I plug it into my formula, it actually becomes a +6. And then my k value just stays +3. From here, my goal is to solve for a, so I will need to simplify the inside of the parentheses first. From here, I am going to square that. And remember that that number goes in front of a. We will subtract 3, which is 18. Divide both sides by 9, and we get that, excuse me, coming over here, we get that a is equal to 2. Now remember that I need my a value and I need my vertex. I do not need my coordinate again, and I plug my vertex and my a value into vertex form. So y equals a times x minus h squared plus k. And that is my equation in vertex form. I will finish the other two as an example, so they'll be done on your completed notes, but that's generally all you need to know for vertex form. If you have any questions, go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye-bye.